Today we're going to look at 7.5, which is solving equations with rational expressions. In the previous section we looked at how to find common denominators, and we're going to use that same trick with our rational expressions to help solve equations. The best way to do it, I would say, is just to look at a couple examples, and we'll use what we did in 7.3 to help solve these equations. So let's look at a simple example. Let's see. Alright, so we have the equation 5 over x plus 2 over 3x squared is equal to 1 over 2x minus 5 over 6x squared. And just like we did in 7.3, we want to look at all of the fractions anytime we're adding or subtracting fractions, whether they're with polynomials or algebraic. We want to find a common denominator. Okay, so we saw before that our common denominator has to be constructed of all of the pieces here in the denominators now. So when I look at all four denominators, the common denominator numerically, right, between 1, 3, 2, and 6, my common denominator, it's going to be 6, right? Because I can build all of these denominators into a 6. I can turn this 2 into a 6 by multiplying by 3. I can turn the 3 into a 6 by multiplying by 2. And I can turn this guy, have this denominator become a 6 if I multiply it by 6. So all of these can be built into a 6. Right, and then the question remains, well, what's my common denominator in terms of x's? What's the smallest amount of x's I need that I can build into? Okay, so in 7.3 we talked about, well, it's going to be actually the highest power that we see. Right? We don't have to build any higher than the highest power that's here. And the highest power of x is x squared. So, right, our common denominator for all of these is going to be 6x squared. And I don't need, just to point out, I don't need any more x's in this. Right, because this denominator already has 2 x's in it. This one already has 2 x's in it. And these two are just missing 1. So I can multiply in an x to both of these, and they'll both be at x squared as well. So this is our common denominator, and we're going to turn all of these fractions into having this denominator. So we can do that by just answering the question, what is this fraction missing? What does it need to get to 6x squared? Well, it's missing a 6x. Okay, and whatever we do to the denominator, we do to the numerator. Okay, what's this fraction missing? Okay, so it's missing a 2. Right, these two would get us 6x squared. All right, this fraction needs a 3 and an x to get to 6x squared. And this fraction already has the denominator of 6x squared, so it doesn't need anything else. Right, now all of our fractions are going to have that common denominator. And we'll just write down the problem again with all of our adjusted fractions. So this one would be 30x over 6x squared plus 4 over 6x squared is equal to 3x over 6x squared minus 5 over 6x squared. All right, and the nice thing about being in an equation with all the terms having the same denominator, we're able to say, well, I'm going to cancel out all the denominators because they all have the same denominator. Essentially what we're doing is we're multiplying every term by 6x squared, and when we multiply by 6x squared, it's going to cancel the denominator in every single situation. So we can throw out the denominators and we're left with an equation that is relatively easy to solve. All right. So 30x plus 4 is equal to 3x minus 5, and we'll solve with our standard movements here. We'll combine our x's. So subtract 3x from both sides. 27x plus 4 is equal to negative 5. We can subtract 4. (27x) equals negative 9. And lastly, divide by 27. Okay, so you end up with x is equal to negative, oh, that can reduce. We can reduce that by 9, so that'd be negative 1 over 3. So again, just a quick run through of that problem. We started out with a problem with a whole bunch of rational expressions in it, and they all had different denominators. So we looked through all of them to find the common denominator between all 4 fractions. No matter how many there are, we'll find the common denominator. We'll turn every single fraction into that denominator, so we can eventually throw out those denominators and just deal with a pretty standard equation in one variable. Right, and solve that to get an answer of x equals negative 1/3. And when you're all done, you do want to be careful, because sometimes when you solve these equations, your answer that you find actually doesn't work. And what I mean by that is we want to go back up into this equation and see if there's a value of x that is unhappy for our problem. And what I mean by unhappy is, we know, since I have a whole bunch of division, 5 divided by x, 2 divided by 3x squared, 1 divided by 2x. Right? Anytime we have division, we have to be careful, because we don't want to divide by 0. Right? Division by 0 is undefined, and it breaks the problem, and it's not a solution. There's nothing good that happens when we divide by 0, so we just want to make sure that we're not dividing by 0. And it just so happens, if I go back to that original problem, right, the only value of x that we're not allowed to use, that would not be a solution to this problem, that could never work. All right, what value of x would make all of these denominators 0 and force us to divide by 0? All right, the only value of x that I can think of, that I can see that would work there, would be 0. So, right, because if I were to plug in 0 here, that'd be 5 divided by 0. That's a problem. If I plug in 0 here, 2 divided by 0. That's a problem. All of these force us to divide by 0 if you ever let x be 0. So it's good news that our answer is not 0, it's negative 1/3, and that answer is going to be okay. All right, but you always want to make sure you don't accidentally run into a solution that is a false solution, because it would break the original equation. So, all right, that's it. That's the idea behind solving these rational equations. The same idea is going to hold no matter what I give you. So let's just look at a couple more examples in our next video, and I think you'll be able to handle the rest of the problems for the section.